Hey guys, very good evening everyone and welcome to yet another session which we are carrying out on various domains. Particularly me, I have been taking care about the sports analytics and these sessions is being organized by 360DigiTMG. So from the past couple of days, we have been discussing about our domain called as sports analytics. We understood what is a sports analytics. As a person who has ventured into a data science and he or she chooses a sports analytics as their domain, what are the different opportunities they have for them? How can they, grab these opportunities? What tips and, traits they need to possess while working as a sports analyst? What is the methodology that needs to be followed? All these things we have been discussing since past 2 days. Yesterday, we discussed about how to carry out exploratory data analysis on our IPL data. Today, we will be going further and discussing about the K-means clustering, how we can use that for sports analytics domain. K-means clustering, we know that it belongs again to your unsupervised learning. So we are going to use our K-means clustering for sports analytics. So today's agenda is what is the sports analytics? Yeah, of course, we need to do a recap on that. We will also try to find out how K-means clustering is used for our sports analytics and what are the contexts that we draw by using K-means clustering on the used example or the data. So again, even before I start with your, K-means clustering, I will quickly try to give you a recap of what is actually the meaning of sports analytics or what we do when we talk about sports analytics. So sports analytics are a collection of relevant historical statistics that can provide a competitive advantage to a team or an individual. Through the collection and analyzation of these data, sports analytics inform players, coaches, and other staff in order to facilitate decision making both during and prior to the sporting event. If I were to summarize what is the sports analytics, this is how I would summarize. In the end, see, it is all about helping your team. And team is nothing but your support staff, your coaches, and your players. You help them in making better decisions, which is going to impact the results or the output of the matches that they are playing. Okay. So today we will be discussing sorry, about K-means clustering. So K-means clustering, guys, as we know that it is an unsupervised learning algorithm that is used to solve the clustering problems in machine learning or data science. K-means clustering groups the unlabeled dataset into different clusters. So here what happens, your K value defines the number of predefined clusters that need to be created in the process. So what happens in the K-means clustering? When we talk about other unsupervised learning techniques, say hierarchical clustering. In hierarchical clustering, what we do is, first we draw a dendrogram. And then we decide the number of clusters. Whereas if we talk about K-means clustering, here number of clusters is decided upfront. That is the basic difference. So here your K defines the number of predefined clusters that need to be created in the process. As if, say, If I define k is equal to 2, then there will be 2 clusters. If I say k is equal to 3, then there will be 3 clusters, so on and so. So your k means clustering. It is an iterative algorithm that divides the unlabeled data set into k clusters in such a way that each data set belongs to only one group and that has similar properties. It also allows us to cluster the data into different groups and a convenient way to discover the categories of the group in the unlabeled data on its own without the need of any training. As we know that when we discuss about unsupervised learning, mostly we will be dealing with your unlabeled. It is also a centroid. Sorry. It is also centroid based algorithm where, so this is a cluster, this is a centroid, and these are say various data points. So how is the centroid, how do you define your centroid or how do you choose a centroid? Suppose you are having a data and say you are having continuous data or numerical data. If you want to find out the centroid, you take all these values and find out your mean. If you have a data set, say it is a categorical data, then you will be using your one. Whatever value you get, choose that as your centroid. This is how a centroid is formed. So, K-means clustering is a centroid-based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of the distance between the data point and their corresponding cluster. So, if we are having two clusters, distance among the clusters should be always high. Distance between the clusters should be always right. So the algorithm takes the unlabeled data set as input, divides the data set into k number of clusters, and repeats the process until it does not find the best. The value of k should be predetermined. As I said, the number of clusters is decided. So the value or the number of clusters in your k means should be predetermined. Now, your k means clustering basically performs two tasks. The first task is it determines the best value for k center point. Or centroid. How? By iterative process. This is one task that your k means does. Second task is it assigns each data to its closest k center. Now, these data points, which are nearer to the particular case center, they form a cluster. And these are the main tasks that your k-means clustering. So what happens? Each cluster has a data point with some commonality, that is less distance between them. And it is away from the cluster. Again, the same thing I was telling you. Two clusters, data point, data point. So each cluster has a data point with some commonalities. Obviously, the distance between them will be low. It means they will be having a lot of common things. Whereas it is away from the cluster. Obviously, the distance will be high. That is why, these data points are in this cluster and these data points are in this cluster. Now, the point comes. Okay, even before that, let us try to understand the context of your k-means clustering. Using a clustering technique along the objective physiological matrix, along with the provided context and analysis from strength and conditioning professionals will create informed training groups that will best maximize the strength of the coaches. Again, we are talking in context to your sports analysis. No, sorry. So when we use your clustering technique along and the objective physiological matrices along with the provided context, sports analytics and analysis from strength and conditioning, professionals will create informed training that will maximize the strength, coaches time and the athlete training. Additionally, the clusters could shed light on what game demands look like for position that might not always fit in the same group, such as linebacker. One way to group the data is by using clustering technique. K-means clustering is a clustering technique that is used to find an optimal number of centers that relate to the data set in such a way that the distance between the centers and the data point is minimized. Thus, providing groups based on any number of variables where the objects in the same group are as similar as possible and objects of the different groups are dissimilar. Distance will be more dissimilar as possible. What are the various steps, or if I say, how does your k-mean algorithm work? So the first step that is being carried out while doing your k-means clustering is select number of k. Why? To decide the number of clusters. Say k is equal to 2, it will form 2 clusters. K is equal to 3, it will form 3 clusters. Then select randomly your k point or center. Now this point, data point which you have selected or centroid that you have selected, this can be other from the input data set. So second point is select random k point. Third, assign each data point to where? Obviously to their closest centroid. which will form the predefined, K cluster. Fourth, calculate variance and place a new centroid of each cluster. Fifth point is repeat the third step, which means reassign each data point to new closest centroid of each cluster. What happens is, say you have various data points. And you assign k is equal to 2. Now what happens is, suppose you took a centroid over here. As and when you will keep running the algorithm, this particular centroid will keep jumping to this cluster, to this cluster, to this cluster, to this cluster. So what to do? We repeat the third step, assign each data point to the closest centroid, which will form the predefined cluster. So we are going to repeat this, which means that reassigning each data point to the new closest centroid for each cluster. Every time it will go, it will form a new closest centroid. If any reassignment occurs in that process, then we go back to step number 4, or we just finish our algorithm. And then your model is ready. Okay? Now, another. How to choose the value of k number of clusters. That is also a big deal, right? If I say k is equal to 2, k is equal to 3, I mean, come on. You cannot randomly choose it. There should be some rationale behind it, right? So what happens is, the performance of your k-means clustering algorithm depends upon, highly efficient cluster that is being formed. But choosing the optimal number of clusters is a big task, as I told you. So what will happen? There are some different ways to find the optimal number of clusters. But let us discuss about few. Say, elbow curve is what we use, or elbow method. Or if I were to show you, if I have this in my slide, bad luck, it is not having. Anyways, I'll be showing you in my Jupyter notebook. There I formed this particular, elbow curve. So when we talk about elbow curve or the elbow method is one of the most popular ways to find the optimal number of clusters. This method uses the concept of WCSS, which means within cluster sum of square, which defines the total variance within a cluster. So we use that. So what happens when we are using the elbow method? There are a few steps that it follows. The first step is it executes the k-means clustering on a data to find the different k value. Let me rather show you if I can. Yeah. So this is how your elbow method looks like. If you observe it, it is just like a human elbow, right? So that is why the name is elbow. Say we have randomly chosen the k numbers, k means k clusters from 2 to 12. Yeah, 2 to 12. So here your k values are starting from 2 until 12. And based on these, various clusters are getting formed. 1, 2, 3, 4, so on. Now, if you try to find out the variance, it is very from this cluster to this cluster, from this cluster to this cluster, very low. This cluster to this cluster, very low. This cluster, again low, very low, again low, again low. As soon as I come over here, that is a big deal. Here also, here. So I will choose my data point until this part, that may be say 5, and I will ask my algorithm to run from your k.5 until your 12. The same thing is what I have done over here. Over here. The same thing is what I've done. First, I tried with the random numbers 2 to 12. And out of this, I chose only 5. Right? This was the rationale behind choosing the number of clusters is equal to coming down. So when you will run your elbow plot, when you will plot your elbow plot, what will happen? It will execute the k means clustering on a given data. For each value of k, it will calculate the within cluster sum of square, the way I was telling. Plotting a curve between your calculated within cluster sum of square values and number of clusters k. The sharp point of bend or a data point of the plot looks like an arm, as I told you. Then that point is considered as the best value of k. Right? So if I were to take you back over here, suppose this is my elbow. Now this is ready, and here I am getting a sharp, this point. So I am choosing this. Or you can draw the lines and observe in the way I have told. Very low, very low, very low, very low, very low, very low, again low. But here we have some very. So we will only choose from k is equal to 5. That is the rationale. So again, I have taken my IPL dataset over here, and this is what it looks like. It had various variables: ID, inning, over, ball, batsman. If I said data.head, it was showing all these values. And by using group by function with the batsman column, I got all these insights from it. I created a data frame with summary and statistics for each batsman. Say A. Ashish Reddy, he faced around 196 balls and he played 20 innings. Total runs he made was 280. It was 16 fours and 15 sixes, so on and so forth for various players, A. Chopra, A. Chandila, A. Chaudhary, so on. I also derived a variable with batsman average and strike rate. What is the batting average? What is the batting strike rate? I tried to find out my distribution of the data, whether it is positively skewed or negatively skewed. And then I found my cluster zone. So I chose 5 clusters. If you observed, I was starting from 2 to 12. I tried calculating my within cluster sum of square for each cluster, to each cluster, 2, then 3, 2, 4, 5, 6, 7. And when I plotted my elbow plot, I came out with an inference that number of 5 clusters is giving me the best insight. Based on that, I found my 5 clusters. And as you know that indexing in Python starts from 0. So 0, 1, 2, 3. Number of players in this cluster, 116. Cluster number 1, we are having 47. That is a 14%. Cluster number 2, we are having 16%. Cluster number 3, we are having 45. That is 13.4%. Cluster 4, we are having 100. That is 30. So 1, 2, 3, 4, 5 clusters and quarter. How we plotted, I will tell you. Coming back to our Jupyter notebook. So I have imported my required libraries over here. I have imported my NumPy, Pandas, Matplotlib, Seaborn, Plot, and so on. I used my dataset which I was having. I was actually having 2 datasets. One I was having for bowling data, and one I was having for match data. Then I said for ball data, give me the head. I got all these values, which is nothing but your top 5 values. Then I said matches data. I found your head. It gave me the top 5 values. I found out the rows and columns by giving dot shape for each of the data sets. I started with doing some pre-processing. I checked for my missing value. For that, I said is null dot sum. If there is any null value, give me the sum of that. So in dismissal kind, clear dismiss, fielder, and extra type, I was having some of the missing values, even in my bowling. I was having some missing values. All these observations I did in my pre-process. Then I created batsman statistics by, grouping your batsman. I said, take my ball data and group by batsman. This is the values which we are having in the batsman, name of the player, R Ponting, RV Maximum, and DB Maximum, so on. And when I said bat group dotted, it showed me your top 5. I created a batting data frame with summary statistics of each batsman. Where we are having summary statistics, here we are having. For say, RP Ponting, non-striker, and it was Maximum, bowler was Nofe, batsman runs was 1, so on and so forth. Various insights I'm having. So based on that, I'm creating a summary statistics for each batsman, like number of balls faced. I'm saying take your bat group ball, count it, rename columns as ball, based on your thought process, right? What happens when you are a data scientist? You sit with your team, you try to figure out various things, or various topics that you need to work about. Various variables that you want to create, you want to drop, so on and so forth. As per my thought process, I thought that it will be good enough to create a data frame with a summary statistics of each bat. So these were the various summary statistics that I took. Number of balls faced, number of innings, total run score, total force that were hit by a player, total missing value, I replaced that with 0. Total 4 hit by a player. Again, I'm missing my total values or missing values with 0. All these are the various things I did to create my data frame for each batsman. After running this is the kind of data frame I got. Initially, I ended up with 537 rows, means I was having 537 batsmen and the 5 columns which I have created. These 5 columns are nothing but here number of balls played 1, 2, 3, 4, 5. Number of balls played, number of innings played by the player, total run scored, total fours, and total fours played by. That is, sorry, total six. It was not four. My bad. Total fours, and these were your variables that I created for each of. And on that basis, I am finding out that Ashish Reddy, he faced around 196 balls. He played 23 innings. A. Chandela, 0-4, 0-6. Balls faced, 7 and 2 innings. He made only 4 runs. So based on that, various insights. Now, I derived my variables for batsman average and strike rate because when we talk about team selection, now think from the perspective of a sports analyst. You are more interested, say there is a player X who plays for Indian cricket team and he goes for a tour in 2022. They say the batsman did a tour of 5 tours international. And in 2023, there's an upcoming tour, international. Now, from the sports analyst point of view, what will you be more interested in? If he is a batsman, you will want to find out that for the last season, what was his average strike rate or average run? These two are very important factors, especially when we talk about events like World Cup. Obviously, you need a batsman with a good strike rate and a good average. Why would you choose a player who is having a slow strike rate or if he is performing below average? No. So based on that rationale, I derived my variables batsman average and strike. Here I am saying take my batting data frame divided by runs divided by innings. All these various parameters I give it. What will be the batting average? The batting average is nothing but your total run number of total run scored divided by number of times the batsman has been dismissed. So here what we did, we approximated to matches instead of number of. So we are taking innings over. We tried to calculate your strike rate also. And strike rate is nothing but your runs scored divided by balls into 100. That will give you whether you have 76% strike rate or 120% strike rate, so and so. And based on this, you choose your variables that you have in your data frame. Choose that. Whatever values you get, assign it to a new variable, batting average and batting strike. So I got up with a new data frame. And again, I said dot and it is giving me profile. So Ashish Reddy, I was having the data till here, but now I'm having this batting average. I'm also having a strike rate of batting. For Chandila also, 57%. Maybe I want to retain this player. Maybe this player. Maybe this player. Maybe I want to give rest to this player. Right? No. Again, it is all about a team. So I created my statistics for the bowlers as well. The way I was creating the statistics for my batsmen. Yeah. I created my batsman statistics. Then I created my bowlers statistics. The same thing I use various variables. Ball group. I try to find out the group detail on the bowler. I try to create a bowling data frame with some statistics of each batsman, number of wickets were there, total number of overs which were bowled, total runs conceded. Now again, these various insights or variables which I chose, it all depends upon your research from the point of view of your domain, say sports analyst. Now, if you are a sports analyst for say a cricket team, and if you want to create a bowler statistics, think in that one. What are the various variables that you would choose to analyze or to rate a bowler? Obviously, you are going to see how many number of wickets he took. Right. Just like your batsman, if we regard Sachin Tendulkar as the god of cricket, for a fact we know he made around 10,000 runs in your test matches. I guess he made 10,000 runs in your ODIs as well. That is for a batsman. But if you talk about a bowler, say Shane Warne, who was, again the king of spin, a very decorated bowler who passed out recently. So from bowler's point of view, all these things, how many wickets he took, how many overs he bowled, how many runs he gave, all these things matter. So I have chosen all these variables and I created. I converted that into a data frame, and for various bowlers, I am getting say balls ball 270, wickets took 18, overs 245, and the run that they gave was 396. So on. Then I also derived the variable bowler economy rate. Like for the cricketer, I wanted to know the average and the strike rate. In the same way, for the bowler, it is all about the economy. Means by how much runs you are giving, how much wicket you are taking. The more less run you give, the more wicket you take, it is said that you are having a better economy. In the same way, using that context, I have took my runs conceded column and overs column, and I have given as runs conceded divided by overs of the ball. That I said that these were the top low plays, top 5. Sorry, below low play, lowest 5. I got if the player's name occurs as a batsman, non-striker or bowler, consider the player has played them. So here I'm getting all the players list with the matches count. This is what I did. I have made a user defined function over here by saying update underscore player underscore with underscore match, various parameters I give. I have also given or made a user defined function over here called as update player underscore list. By using this, I am trying to add each player to the final player list. By defining this function, I am trying to consider the player listed as a batsman, non-striker, or as a bowler. Then I am trying to create a data frame on that, and then I have merged the player statistics. Batsman data frame I created, bowler data frame I created, I have merged both. And then when I say players.head, the player Ashish Reddy, matches 28, balls faced 196, innings 23, runs. Along with that, it is also giving me his batting average, batting strike, balls bowled, wicket, overs, runs considered. Now this is a more insightful data compared to the previous. What if I add number of catches to statistics? Is that going to give me his, agility state on the field as well? How agile is my player on the field while fielding? That is an important aspect. How can we forget that? So here I have created my number of catches status. total number of catches is equal to number of pots plus board divided plus number of catches as a fielder. Captured pot and board instances. I've used my various variables which I was having in my data set, which is your bowling data. I've used that and I've created a data. And if I say players along with all this information, now I'm also getting your catches information. That Ashish Reddy took 9 catches. Why we Takavale? He took 13, very agile. But not more than Yuvraj Singh. I mean, come on, he took 31 catches. Zahir Khan took 21 catches. Marvelous. Man of the matches from the last season. Obviously, we needed that. So various, variables I kept on adding, and I tried to see. I also removed the players who have played the less match. Backup players that we have. Various things are good. I have done my plotting. I tried to find out, what is the data distribution, all these things I did. Then I did the scaling. So I'm using my standard scaler. Obviously, we know that if we are having, values, say 9,000 and say 20, that is a big problem, right? It is going to hamper our analysis. So for that, we scale that data. Upon scaling, this is what we do. So I have scaled my data over here so that it doesn't hamper my analysis. Then I found the mean around your 0 and the standard deviation by saying dot describe. I got all these values. I have updated player names as your columns over here. These was the player, so I have given the name over here. And then I have finded optimal number of clusters. In the end, it is all about k-means clustering that I was talking about. And in k-means clustering, we decided that we choose the number of clusters upfront. So here I am saying that I want to choose from 2 to 12. Means I want to form k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5, so on and so forth till k is equal to 2. So many clusters it is formed. Again, I made a user-defined function. I am taking minimum value. Take the minimum value of k, that is 2. Take the maximum value of k, that is 12. On the iteration of 50, sum of square distance I kept as null. For k range, I am taking take the range maximum and minimum. Maximum should be k plus 1, means it should keep on adding 1. Number of clusters I gave is equal to k. So first it is going to take 2 and the value which I get, we are going to append over here. Then it is going to take 3, then again it is going to append over here. Then 4, then 5. Because that is why we took sum square distance is equal to null. We want to append these values. I wanted to run this algorithm, so I said k-means dot fit players underscore state. I mean, this is a data set which is in its best form. I wanted to run it on my scaled data. Sorry, this scaling has been. So I am running over. And this is what I am. Again, the same thing. What I was telling you previously, few minutes before when we were discussing about this slide. So you choose various clusters. Here I have chosen 2 until your 12. 2 until your 12 on the iteration of 50. On that basis, I got various clusters. Then you choose this 5 data point as your best data point, and then you start doing your performance. So we started, or I started doing my k-means clustering by choosing k is equal to 5, and even before that I have to import my k-means that exists in your sklearn.cluster. Then I have defined a function to perform my k-means clustering on the given. So again, I have taken num underscore clusters, maximum iterations I have taken, input underscore data frame, output underscore data frame, output underscore column, various things are. Then I have assigned the label to the output column, that is the output underscore df and output underscore column. Here what I did was I have my new output column called as a k-means cluster. Should be your name of the k-means label. To perform my k-means clustering, see over here. This is the point of our entry. Now I am doing my k-means on scaled data, that is players underscore date scaled. I have taken all the column underscore names players. K means label, that is a cluster means I am applying over here, and I am taking my 5k pointer. Now I am viewing few entries from each cluster. I am getting some output. So your player number, your player S Nadeem belongs to cluster number 0. So here we are getting one cluster, that is 0, two cluster, that is 1, three cluster, that is a 2, four cluster, and 5. So we have 5 clusters. We chose K cluster. And based on these 5 clusters, we are clustering these, that this player belongs to cluster number 0, 1, 2, 3, 4. So Jakati belongs to 0, as Suresh Rana belongs to cluster number 2, and Y Venugopal Rao belongs to cluster number 4, so on. Viewing the summary of the cluster, this is what. So players in each cluster is what you are seeing here. Various clusters I made, total 5, and number of players in each cluster. In this cluster, we have 34.5%. In this cluster, we have 33.3. Then 14%, 4.8%, 13.4%. Good for analysis. As a sports analyst, when you want to draw the insight to your say team, which comprises of coach, players, and say support staff. Obviously, the stats that we did upwards, that is not going to make much more sense. But these kind of graphical representation is using, and it is more useful for you to draw the more correct insight. So this is how we do our k-means clustering. People who want the data set, I got some requests for the data set and the code. Please forward your email ID to me. I guess everyone is having my WhatsApp number. So when we will be ending this domain analytics by next week, I will be sending all the data sets that I have used. I'll be sending all your Jupyter notebook code on your respective email ID. So this is where we are going to stop this session for today, guys. Thank you.